So everyone that's joined us today, this is one of our first webinars, so we're still working through some of the technical nuances with using Zoom webinars and all that stuff. So just bear with us if we have some little glitches, okay? Um, Luckily, we're new at Zoom, but we're not new at drones. So luckily our drones don't have glitches like we're having here. So anyway, I'm Brian Sanders. I'm the president of HSE-UAV and just really glad to have you here today. So thanks again for joining us. And with us, I have Simon Aslan, and Simon manages our training team. He's our chief pilot, chief flight instructor, and also heads up our after-sales service department. Does a lot of our technical guidance and consulting and engineering work. And you'll see with the virtual background he's using, sometimes he has these white parts over his eyes and can do cool stuff like that. And then Joye is also here. And Joye manages all of our events, including and our services. So she actually oversees our training programs, like the delivery of those, along with our FAA services, and just works with a lot of our social media aspects and things like that. So you guys, thanks for being here with us and looking forward to jumping into some of these questions. Cool. Simon, Joye, anything else you guys want to say?
Just thanks for being here, you guys. We're looking forward to it.
Cool. So to all of our folks that are joining us, I want to walk you through some things on Zoom in case you're not familiar. So right now, the way it's set up is that Simon, Joye, and I are all panelists, or we're hosts of the meeting. So you'll be able to see our video when we're speaking. If you want to change the video, how you're seeing it, there's different ways to make your screen full size or smaller. If you need some help, we'll go through some other options too. There's also a poll. So we might send you a poll that will ask you a question like, what industry are you in? Or, what's one of the things you want to know today? And there's also a Q&A, which one of you have already figured out how to use because you asked the question. But at the bottom of your screen, regardless likely of whether you're on a PC or a Mac or a smartphone device, there's a section at the bottom that says Q&A. If you click on that, it's going to give you a chance to ask a question. Now that comes right over to us so we can see your question, and it will either answer those questions live, like we'll speak about it live like this on video, or we might type the response back to you. So just keep an eye on that. It'll notify you when we've replied. So just be ready. So go ahead and submit any questions that you have now through that link. And if you already submitted your questions earlier when you registered for this, we're going to get to those today as well. Now, I do want to remind everyone with us today that this webinar is a focused session. So we're talking specifically today about drone technology, the features, software, integrations, all of the technological aspects of drone technology. But we're not really going to do much of a deep dive into other aspects of like spray research or FAA or licensing. Those we have specific webinars that are focused on those topics. So Joye, when is the next FAA webinar? When's that happening?
Tomorrow, same time. So if you guys want to come to it's drone spray compliance webinar, you can reply back to either the reminder you got today and I'll send you the RSVP link, or we'll also send out the link with our compiled questions and answers if we haven't been able to get to them live today.
Great.
You can reply to one of those emails and we can get you invited to the FAA one.
Perfect. All right. Thank you. That's excellent. And then, to everyone joining us online, we do intend to have these, especially now, because I think like all of us, we're working from home. So we intend to have these webinars ongoing and hope that they're of great value to you. So just thanks again for joining us. And we're going to jump right in. So we've got a couple questions here. And then Simon, do you want to start going through the questions that folks submitted during the registration? And then I'll start working on the questions that people are submitting to us live.
Sure, that'd be perfect.
Cool. And your audio sounds great. Now, also, as a reminder to all of our attendees, you will see us also typing and doing all sorts of other distracted things because we're responding to your other questions, okay? Now, once we answer your questions, then that question will be visible to everyone else that's joined us. So, for example, Alejandro asked a question. When I answer it, anyone that's joining us today can click on the Q&A and see the question and the answer. So just keep an eye on that little Q&A bubble, okay? All right, Simon, I'll turn it over to you.
All right, so let's get started. I have a couple questions that were submitted prior to us starting this webinar, so we'll get started with those first. Let's see here. So one of the first questions that we got is a question about swarming software and where we're at with swarming. So a couple things with that. First of all, swarming is already possible with our existing software. What's not possible currently with our software is the ability to fly multiple aircraft from one single controller. So we can fly multiple aircraft, but each aircraft has its own controller. My personal preference is I actually prefer that. I think it's a lot safer. In case there's an emergency, the pilot can very quickly take over control of the aircraft. Now, we are looking into possibilities in having the ability to fly multiple aircraft from one controller and being able to switch from, for example, drone 1 to drone 2 to drone 3. And that is likely something that we'll see coming in the future. In addition to that, there are also some things to keep in mind with the regulatory side. And we're working with that as well with our consultant to be able to fly multiple drones at the same time in the United States. And we actually already have customers doing that. So we're really excited to have that.
And let me add just a little bit to that. Currently, unless you have a Part 107.35 waiver to operate multiple aircraft, or an exemption, like if you're operating over 55 pounds, it can be written into your exemption. And the customer asked if we had a US-based company that we're familiar with for swarming technology, or the software, I'm sorry. We don't currently, off the top of our head, can't think of one, but we are going to do a little research and talk to a couple of our partners and see if we have a US-based source for that too. So we'll send that out in the follow-up questions too.
Great. Okay, another question that we got is, what is the feasibility of using UAV sprayers for herbicide applications in forestry?
Hey,
and actually, we already have.
Real quick,
Yes.
before you go
Sure.
on to that, because I think swarming is something that's on the minds of a lot of people.
Right.
And just something I'd like to add to what you said already is, we think about the technology evolving in a couple different ways, and this actually answers some of the other questions that folks have answered or asked. So, we've got two different ways that we can have more coverage from drone technology. So we have one is battery propulsion or different engine types, which we'll cover a little later. So that would actually, larger batteries, lighter batteries, more powerful batteries give us the ability to actually carry more payload, right? So that's one way that we could solve that problem, is by better propulsion technology. Now we are, of course, at that case, we're kind of held up waiting for that technology to develop. And of course, there's a big demand for that, but there's a lot that would have to happen for that technology to really advance to the point where we could carry 30, 50, 70 gallons or liters. So right now, the thing that's really attractive to a lot of us, companies like ourselves and customers, is instead using multiple smaller drones as a swarm. So maybe I have 3 10-liter drones flying all simultaneously and effectively, getting 30 liters out in that same time frame versus one 30-liter drone. There's also some benefits of redundancies, so if there's a problem or an issue with one, you've got 2 others that are still operating. So I think the question is really great and something that we're keenly interested in. And like Simon mentioned, right now the regulatory environment is running a bit behind the technology. So I think that you'll see a lot more of the swarming technology and a lot more cloud-based management of fleets of drones. So stay tuned for that. We've been testing this kind of technology in Asia for several years now. It works great. There's some infrastructure changes that we still need, like 5G networks here in the States, to run the kind of speed and bandwidth that's required. But it is coming. So I just wanted to chime in and add that, Simon.
Right, and one more thing that I want to mention real quick. There is a point of diminishing returns with the size versus cost, and that's why a lot of people are interested in swarming. The cost to build a larger drone is exponentially higher for every liter that you add for capacity. So it's likely a lot more effective financially and possibly on the spraying side as well, to have multiple smaller drones versus one big drone. Okay, all right, let's go ahead and move on to the next question. So this is another question that we had sent in. What is the feasibility of using UAVs for herbicide applications in forestry? That's a really good question. We actually have quite a few customers using our drones in forestry applications. As I'm sure you know, the application and the type of application, herbicide application in forestry varies dramatically depending on the type of application. But as a general guideline, what we've seen for forestry applications specifically is the need for a fairly high application rate. So what helps with that is having larger, higher output pumps and also higher output nozzles. So that's actually something that we're doing more testing with to see what is most effective. Some of our newer models like our M6EX and our M6A Pro models actually come with dual pump setup, and they're actually capable of up to 6 liters a minute output rate, which really increases your efficacy. By having that higher output rate, that means you don't have to fly so slowly to achieve, for example, a 4 or 5 gallon per acre application rate. So that efficiency goes up dramatically. And I see that we have a lot of questions coming in, so I think we can move on to the next questions here. I want to make sure that we cover as many questions as possible. If you guys do have any additional questions and anything that maybe we didn't cover as thoroughly as you'd like in this live webinar, definitely feel free to contact us through our website. We have our chat on our website and also our email and our phone number on there as well. So if you need a little bit more one-on-one time, that's going to be the best way to contact us. Okay, let me take a look at these questions here. All right, let's jump in some of the questions that have come in on our Q&A. All right, for Alejandro from Chile, what type of mixtures do you not recommend to use to avoid clogging the nozzles? What we found is certain surfactants that are used in a lot of spray applications tend to cause issues with the nozzles getting clogged. There's a limit to the amount of specifically surfactants that you can add to the nozzles. What we found is if you add too much, that the nozzles won't actually, what's the word, I guess atomize properly, and you'll just get a stream rather than a nice mist. So there is a limit to how much you can add. Part of that also has to do with the size of the nozzle and also the pressure from the pump. We definitely recommend following the label's prescription for that, for the best application. Let's see, what is the maximum slope you recommend working? We have slopes greater than 45 degrees. That's a really good question. So most of our drones have radar terrain following systems, and they actually work really well even in really steep terrains. There is a limit to how fast you can actually fly based on the angle of your slope. So in a very steep slope, you can't fly as fast as you would on a less steep slope. So for a 45-degree slope, obviously that's very steep, you'd have to limit your speed. Also, the terrain that you're actually flying over will have an effect to how accurately that terrain sensor can sense the change in grade. My recommendation for flying in that type of condition, the most effective way is to always fly parallel to the slope rather than up and down the slope, perpendicular to the slope. There's two things that you gain by doing that. Number one, you use a lot less battery because you're not climbing and descending as much. When you're flying parallel to a slope, you're only climbing and descending for each row that you move over. So instead of climbing and descending up and down every row, you're only doing it, it's a lot less battery that you'll use. That's my first recommendation. It's also, I think, safer to operate in that way because you're relying less on the terrain sensor to adjust for differences in slope, rather than constantly adjusting while going up and down the terrain. I understand that's not always possible. But when it is possible, I always recommend flying that way. You really increase your flight time because climbing and descending on the drones is really, really power intensive, especially when the payload is full. So you had a couple other questions here. Do we have any experience in application on sloping avocado and citrus on flat terrain? Good question. I have to see if we have any customers that have sloping avocado specifically. We definitely have a lot of customers flying in sloped terrains. That's definitely not an issue. There are some things to keep in mind with the terrain sensor. In some cases, especially if you're flying over trees like avocado trees on slopes, you can have issues where the difference in height between a tree and the ground is too great, and the terrain sensor won't be able to compensate for that change in altitude quickly enough. In some cases, the best thing to do is actually adjust the height manually. What's nice about all of our agricultural spraying drones is that even while it's flying its grid, for example, autonomously, you're able to adjust the altitude manually while it's actually flying autonomously. So again, if you're flying parallel to a slope, you only have to adjust the altitude a couple times typically in a normal situation. In a lot of cases, especially flying over trees, that's sometimes the best option. Of course, by doing that, you do have to always be keeping an eye on the drone and having a visual line of sight. So that's as far as citrus on flat terrain is easy for a drone. When there's no change in grade, we essentially leave the terrain sensor radar off and use our standard barometric altimeter that's built into the drone. That will maintain the altitude throughout the entire flight. So flying over flat terrain is no problem at all. Lastly, what model of drone would you recommend?
Before you move on, I just want to add something to what you said, because the technology over the years has really improved when it comes to the altitude hold ability for the aircraft.
Right.
It used to be, I think, 4 or 5 years ago, when we first brought these to the Western kind of hemisphere market, the altitude hold ability was really, really, really pretty poor. You might have a variance of a meter, 3, 4, 5 feet, and there wasn't a consistency along even flat terrain. The drone would climb and descend. Just the sensor resolution or the quality just wasn't that great at the time. And what we see now, just adding to what you said, Simon, is like over a flat ground or flat crop, even if the crop height is different, turning off that terrain sensor, the aircraft holds a really, really, really solid, like pretty perfect altitude just consistently.
Exactly. So
it's
on our models with, if you're flying it without the terrain sensor or with the terrain sensor off, we really never see more than at worst case scenario, 1 meter of variance in the altitude. And that's actually really, really good for that type of use. That's in the worst case scenario. Typically it's, much, much less than that. And if you use RTK GPS, if you have the RTK option, that is reduced.
Oh, hey, Simon, you're cutting out. We couldn't hear you.
Oh, I was saying if you use the RTK options that are available in some of our models, that variance is decreased even further. So if that type of accuracy is really important, the RTK is a good option to have.
Awesome. Cool. Simon, I want to jump into one of these other questions. Sure. Pretty great. It says, this is from Christian, and it says, are you thinking of trying other types of engines that could give more flying time and include removable tank containers? And I'll let you
Great.
answer that, or I could.
Sure, I can answer that.
Sure.
So for engine types, we've been looking at other alternative options. So right now, most of our models are standard electric drones with either 6 or 8 electric motors run by typically a lithium polymer battery. There's a lot of good things about this. It's extremely easy to use. It's very, very robust. It basically always works. You just have to plug in the battery and it works. It's a very simple method. The downsides, of course, are the flight time. The cost of the batteries is another downside. And then, of course, you have to manage all the batteries. You have to keep the batteries charged. You have to have enough batteries to be able to fly continuously and have enough chargers to keep the batteries charged. So we've looked into alternative options like a hybrid electric. And what that is it's essentially the same layout as our electric drone. So there's a set of electric motors that actually provide the propulsion. But in this case, instead of having a battery to run the motor, would have essentially a gasoline generator on board the aircraft. It's a great concept. What's fantastic about that is that it removes essentially the need for having batteries, the chargers, and it's still a simple operation because it's still powered by electric motors. There's only really a generator that runs those electric. There's still some disadvantages to having a gasoline aircraft as well. Typically, the payload is reduced because you also have to carry the payload of the gasoline to run the motor. So for an aircraft that carries 10 liters, it's actually typically larger than an all-electric 10-liter model. So you tend to lose a little bit of your payload ability, or rather, you have to have a larger aircraft for the same payload. A couple other concerns that you might have with a gasoline electric model is typically most of these aircraft run on 2-cycle engines, and most are, at least currently, and again, we're looking at other options, most are carbureted engines. So there are concerns with varying altitudes require specific tuning for the engine. So there's advantages and disadvantages to both. What I see is the best entry models are all electric models because they are extremely reliable. And let me back up a little bit. Most of the gasoline electric models also have a backup battery. So for any reason you run out of fuel or the gasoline engine fails, you can still land the aircraft safely. Is there anything you want to add to that, Brian?
I think it's really great. You know, it always is going to come down to that perfect power to weight ratio, right? And also give operators in the field a really easy experience. And the good thing about electric is that it's just easy. There's very little maintenance. You don't have to bring out fuel or oil or deal with, you know, exhaust or letting the engine cool down before you can transport it again. There's a lot of those challenges that we heard from customers. The noise, the vibration creates so much vibration in the frame. There's a lot more maintenance of tightening and reconfirming things. That was some of what customers didn't like about this hybrid system that we used. Also, several years ago on a different project for the US military, we were working with a gas turbine engine, which is also some of the things that people ask, literally a jet engine. The problem with those is that they spool, the revolutions are so fast, those engines turn so fast, we couldn't find transmissions small enough, light enough, again, all about power to weight, that would actually hold up longer than a couple, I think we get 10 or 15 hours out of it. So the maintenance became a big problem. Yeah, you're not charging in the field, but you know, the downtime, the maintenance time required was significantly more.
I'm really glad you brought that up. That's actually, again, that was one of the biggest complaints from our customers is there's a lot more maintenance involved with a gasoline engine. That's just the nature of it. Just like your car requires constant maintenance, so does a gasoline engine on a gasoline electric hybrid model. And what we found is even though batteries are expensive and then you need to have the chargers and everything involved with it, you know, when you take into account the cost of the maintenance and the disadvantages of some of the disadvantages of a hybrid model. And with the new technology of the chargers that are coming out for the electric models, being able to charge faster and faster and being able to charge multiple batteries at the same time, it starts to become tough to choose between the two, especially when you consider the reliability concerns with gasoline engines. And most of these two-cycle engines require very specific oil mixtures that are actually quite expensive and premium fuel. A lot of them require non-ethanol fuel, which you can't find everywhere. So there's a lot of, there's always two sides to the argument. I really do believe that the hybrid models, with the new technology and maybe with fuel injection systems, will definitely play a factor in the future. Okay, I think we can move on to the next question.
Yeah, Simon, I'm going to bring in one of the other questions that's just right on the tail of what you're saying here, and that's from Elon, and it says, I'd like to hear your view on batteries, cost, performance, maintenance, etc. And one of the things that you'll see here is that our older models used to have 4 batteries at one time to fly, okay? And it's fine. We just didn't have a large enough, powerful enough battery that had all those 4 combined into one. So we had 4 individual batteries. You had to hook them all up. Mm-hmm. Downside and the lack of efficiency came when it came time to charge those batteries and transport those batteries. Then you have to take all 4 of those off, carry them right in your arms like this. And then most of your chargers really only have enough power to pull out of the wall or the generator to be able to charge 2 of those at a time. So then you had either 2 different chargers charging all 4 at a time, which took about 40 minutes to charge 2 batteries. So that required, really, customers might have 8 or 10 sets of batteries to be able to have back-to-back flight operations, right? Charging 2 batteries for 40 minutes. If I have 2 chargers, I can charge 4 in 40 minutes, but then I'm flying batteries at 15 minutes or so. So I go through 3 cycles of batteries almost before my first 4 were finished charging. So what we've been hard at work on, along with our battery manufacturing partners, is taking those 4 batteries, packing them into one big battery that's 58 volts instead of 22 volts. And now it still takes me 40 minutes, but I'm charging one battery in 40 minutes. So now I've got a charger that charges 2 of those batteries in 40 minutes, and I'm flying 1 battery at a time. So to answer your question, Elon, really that's what we see more of, this future going, is that we're going to have larger physical batteries with higher voltage. We're at 58.8 volts now is our biggest. That's 14 cells. The next one after that, if we get to 15 and 16 cells, physically they'll get larger, they'll have higher voltage, which gives us more of an ability to fly longer and more efficiently. The other thing we've been optimizing when it comes to batteries is that's also more convenient, right? Because you're carrying physically 1 battery around, 1 in your truck, 1 in your ATV, instead of carrying around 4 of them at a time. So way easier for transport too. The other thing that's really critical that, we weren't great at when we first started this, of course, because there's a learning process with the technology, but it's optimizing flight time and spray time. Because some of our earliest models years ago, you'd end up running out of chemical at 10 minutes, but you'd have 6 minutes of battery left. So now you haven't really used all your battery, but you've got to land to refill your tank anyway. So you're trying to find this perfect balance between, I want my spray to run out at the same time, a little extra cushion on the battery, of course, for getting back to your landing spot. So all of our aircraft now are pretty optimized so that on average, based on your application rates, you're going to run out of chemical about the same time you'd run out of battery. Land the aircraft, pull 1 battery off, put 1 battery back on, and then refill your tank and take off. Cost, the other question about that, Elon, was cost. Battery costs are coming down. So even though our newest large battery is almost $1,000, it's actually cheaper than 4 at $350 a piece. So the price per battery is higher. However, it's less expensive per volt, if you will. And we are seeing the performance is increasing with this technology too. increasing in ways that you're getting more life cycles out of that battery because you're not mixing all these batteries in flight together. We're also finding that the battery management systems, like BMS is what that's known as, has also evolved significantly. There's actually AI technology, like machine learning software, that's managing that battery for you. Our batteries have Bluetooth connections now, Wi-Fi connections, onboard diagnostics. I mean, it's just crazy. And that's all happened in the last, Simon, what's that been? The last 2 years, maybe?
Right. I mean, it's amazing how much that's progressed. And the battery, I'm glad you brought that up. The battery management system is really the critical item to the longevity and the performance of the battery. The new batteries, some of the new batteries that we offer for M6A Pro G200 model, like you said, have actually the ability to connect from your phone. And, you know, that seems kind of trivial, but it actually provides a lot of really good information. So it actually can manage the cycle count of the battery. So you don't even have to keep a log of it anymore. Beyond that, it automatically stores the battery after a certain amount of time. So if you forget to put your battery in storage mode, which is one of the most important things about the batteries, if they're not used for long periods of time and you leave them fully charged, you can almost bet money that they're going to be damaged over time. So that kind of takes care of it for you, which is incredibly handy. And again, I mean, just a couple things, but the software will tell you the cycle count. It will tell you if it's ever had any faults, like over temperature, under temperature, over current, over voltage, under voltage scenarios. So it makes the management of the batteries a couple things, much easier. It's a lot safer, and it's going to last a lot longer. So, and then one more thing, with the batteries matching the spray time more closely, that brings the overall cost of the batteries down because you're not paying for too big of a battery for your drone. You're matching the size of the battery perfectly to the size of the spray tank, so that you're not essentially wasting your battery. It's better matched.
That's perfect, Simon. Thank you. The next question we have says, regarding spray drones, are any drone manufacturers working with pesticide manufacturers to come up with prepackaged pesticide applications? And then is the USDA/EPA, you know, how is all that impacted? So to connect all of this, so one big improvement with our new models, be it the M6EX2, which is our 10-liter model, really popular aircraft, people love that machine, and then our newest 16-liter aircraft that's based on the same design principles as the 10-liter, so it's large, sealed airframe, so decontamination, rinsing is super easy, inexpensive for parts and repairs, all that stuff is great. So the big part that we've heard loud and clear from customers over all these years is we want the ability to swap tanks really easily, like no hardware needed. You know, I don't want to spend half an hour. We had some folks that bought a competitor's drone that took, Simon, it was like all day to be able to replace parts on
right.
one of those other spraying aircraft, right? So our goal is to have everything be quick and easy, and the ability to swap a tank in the field allows you to do a couple things. One, decontamination is super simple because you can literally separate herbicides on this in this tank set and, you know, fungicides on these. It also gives you the ability, if you have extra tanks, you know, in the field with you, you can have those all filled, ready to go. So when you land the drone, you know, you can, depending on which aircraft, either pull 2 pins out, the tank drops down, you put the other one on, put the pins in, and you go. So that's a really big improvement as well that's happened. Now, regarding the manufacturers working with pesticide manufacturers to come up with prepackaged pesticide applications. All right, so I'll take this one, Simon, because I've been heavily involved in this aspect. So right now, generally speaking, and I'm speaking specifically from how the regulations work here in the United States, okay? It could be different for our folks that are joining us from different countries. Right now, the requirement is that you follow an aerial label, okay? And the challenging thing about that is that the recovery rates of drones are significantly higher than recovery rates of traditional manned aerial applications. A recovery rate is something a chemical company uses, and it says how much of the chemical leaves the nozzles versus how much is captured on the ground. In other words, how much drifted off target or how much evaporated, okay? Typical aerial labels account for 60 to 70% of that application actually hitting your coverage, hitting your target, okay? Meaning that 30 or 40% has either evaporated or drifted off target. Whereas with drone technology, because we're closer to the crop and because we have that downward thrust, we actually have on testing about 90% recovery rates. So meaning much more actual chemical is captured on the target versus evaporating or drifting off-site or off target. So all of those things considered, chemical companies know that there's a value and benefit and it's necessary to come up with application labels for drones, but they're not there yet. We do here in the States and some international chemical companies as well, but we work directly with Bayer Chemical along with Monsanto, Legacy Monsanto, and some other folks as well. And every chemical company that we've talked to and worked with is interested and committed and working on having labels specifically for UAVs and drones. So that's where we are right now in the regulatory environment. So are we working with them? Yes, absolutely. I can't speak for our peers in the industry and what they're up to, but we definitely are. And then let me just look at, nozzle manufacturers as well. So typically what we see, and we have a lot of spray research and testing that was done by the USDA to create kind of an industry standard. But currently what we see is air induction nozzles work really beautifully, both at mitigating drift and having the coverage that's really necessary and needed. So air induction looks like the best thing. We've got a good consistent spray pattern while not having, while being able to effectively mitigate drift. Again, it's always about, using the nozzle based on whatever the product is that you're applying. And when drift mitigation is important, that you do that. And when it's not, then you can go with more coverage. T-Jet is a company that we work with, and they're actually out to build and develop a nozzle that's customized for UAS or drone applications. So that's super exciting. We'll hear more from them towards the end of the year, but that's something that they're already in the works of. And I think we'll see other nozzle manufacturers like Leckler also kind of following suit. I think that's all that I'd say to answer that question. And then let me jump in and see, let's see. I'm looking, Simon, any other questions that you see that would be related to that one that we could just hook together?
Let me see. No, I don't think so.
Okay, good. So that was a question that one of you submitted online on the web before. I also just wanted to remind all of our guests today that we've got about 6 minutes left. So any of your last minute questions or anything that we haven't addressed, make sure you click on the Q&A at the bottom and submit your question that way. That way we'll ensure that we follow up and get all of your questions answered if we don't get a chance to answer them live. And then Simon, I'm gonna have you jump back in and, I'll tap on, Elon had another question about our view regarding a heavy payload spraying drone. So maybe up to like 30, 50, 100 liters. Right now, that isn't really feasible, mostly because of that power cell, the battery, the propulsion technology. Certain applications could benefit from like having a tethered system where power is on the ground and maybe you've got a big 200-gallon tank or something like that with a ground pump. That could be beneficial if you're doing things like roof spraying. We have some customers that do that. It's pretty ingenious. However, in typical agriculture and fields, carrying a hose and a power line through a crop and then having to switch rows, have the line hung up and snagged, it's not super feasible right now in agriculture. Could it be? Absolutely. Is there some engineering work that would have to go into it? Totally. Right now, we're seeing more along the lines of what we said earlier about swarms being the most effective and efficient way to solve that. And Simon, I'll turn over to you, going back to some of these other questions, okay?
Sure. So I see a question here from Leo. Will the drone operates the same over water or land. And actually, yes, it will operate exactly the same way over water and land, with one key thing to keep in mind. When you're flying over water, you need to have your terrain radar sensor turned on. Of course, over water, you don't have issues with terrain changes, so it's recommended to keep it off just to make sure you don't have any erroneous readings. But absolutely, the drone can fly over water, no problem at all.
And Simon, I think a benefit of that it comes into management of like vector control, mosquito abatement, or managing invasive aquatic species. So a lot of times customers will have drones flying over waterways to treat those kinds of concerns. So that's a really great question that Leo asked.
Okay, moving on. We have a question here that we kind of already answered. I'm not going to spend too much time on it. Are you folks doing anything in the way of drone swarming, working with other companies, etc.? Yes, we actually answered this at the beginning of the webinar. We are looking at the drone swarming technology, specifically being able to control from one source. Let's see. And I know we only have a few minutes left, so I'm kind of trying to get all these questions answered. And again, if you have any additional questions, feel free to go to our website up here and contact us through there. Let's see. There's a question here regarding shipping batteries. The size batteries that we use really need to be shipped via ground methods. There are ways to ship it via air, but I think it's very complicated. So the batteries can be shipped via ground shipping methods. They just need to be labeled correctly on the box. You can find the specific type of labeling that you need on FedEx or UPS website. Let's see here. Chemical tables specifically regarding needing spraying volumes per acre are adjusted to crop dust, or can we use different volumes of drones? Yes, most of the testing that our customers and that we have done or affiliates have done have shown that the efficacy with a drone tends to be better than from a traditional crop sprayer. The issue right now is that we have to follow the labeling requirements on the specific type of chemical that you're using. Like Brian mentioned earlier, most of the large chemical manufacturers are already working on labeling specific for unmanned aviation or drones. We will begin to see that soon. If you are in a country where that is not a requirement, then typically we see quite a percentage and increased efficacy by spraying from the drone.
And I'll just add on to that one, Simon, real quick. You know, there's I don't want anyone to be left with the impression that drones are better than manned ag aviators. And I know that's not what we're saying, but I just want to make sure that's really clear. There's a really great need for both. And I think, and our company's perspective is that drones really are complementary to and not a replacement of. Now, in the future, look, in 20 years, will drones be spraying fields at massive, capacities? Probably so. That's very realistic, right? However, right now, we're not there. So looking at ways that drones can complement existing manned aviator applicators is really, really where we're at. And then also places that are tough to get to. So places that it's not safe or not financially viable or feasible for a manned applicator to go in. You know, whether it's a soil compaction issue or a terrain or a hillside, or maybe the crop would be damaged by bringing in a manned ag aviator or a ground rig. You know, drones are great for that. A really simple rule of thumb is if there's a backpack sprayer, that can be beautifully replaced by a drone. So some good places to look. So I just wanted to make sure that was clear what we were talking about earlier with recovery rates and all of that stuff. That's a totally fine and acceptable recovery rate. It's vetted by the EPA and there's not a problem with it at all. I was just pointing to the efficiency. The labels haven't caught up with the efficiency of drones yet. So cool. Thanks, Simon. And we're just about time here, but let's get to that last question there, Simon, about COVID.
Sure. Let's see. Any delays in production commercial units with COVID-19 COVID-19 scheduled for the next 3 months in terms of drones or technology? Great question. The COVID-19 situation definitely put some delays on some of the shipping from our manufacturers and the people that we work with. However, it seems like we've actually caught up. We haven't really seen any significant delays to where we would say that we'd have to discontinue a product or anything for a certain amount of time. So as of now, our typical shipping schedules have been unchanged. Our manufacturers have been really great with working with us throughout this whole situation. So really the only delays that we see now are normal delays through our typical shipping companies like FedEx, DHL, UPS. They are running a little bit behind just because of all the situation that's going on. But as far as our actual suppliers, no, we're actually fairly caught up with it. We're really happy to say that.
All right, great. So again, thank you for joining us. We're just so glad to have you here. I know we went a couple minutes over and just wanted to get those last questions answered for you. And remember, if you submitted your question online before, or if for some reason we didn't get to it today, we will be sending out a debrief with all of those questions, both the ones we answered live and the ones that you submitted to us before. And just thanks for joining us. So Joye, again, the next webinar series that we have is when?
There, I'm back. I was muted. It's tomorrow, same time, and you guys can reply to any of the emails or info@hse-uav.com or contact us on the website. If you wanted to get the invitation link, I'll send that to you guys.
Great.
And then we'll get, we're going to post this recording on YouTube and compile some questions and answers and hopefully have that done by end of the day tomorrow is our goal.
Excellent. Perfect. And then just stay tuned, everyone, for future webinars that we have. And again, they're targeted focus groups, right? So today we focused mostly on the technology aspects. Tomorrow is all about FAA and compliance. So all of those kinds of questions, we'll have one of our specialists. And then next week, we're going to be we're always looking for specialists in certain fields. So we're going to be looking at having some folks that specialize in NDVI and imaging join us. We'll also look to see if we can get Dr. Dan Martin with the USDA back to join us for some research stuff. So just stay tuned. So thanks again. All right.
Thanks, guys.
All right.
Stay safe.
Take care, everybody.